Hello and welcome. So here today we have ax squared plus bx plus c equals 0, which you know is the standard form for our quadratic, and we want to complete the square on this guy. So hopefully you've watched the two previous examples, the previous video that had examples. If you have not yet watched those, I strongly urge you to go ahead and get on there and watch those two examples, the previous video. Make sure you understand this stuff before you watch this video, because this video is going to be a little bit more complex, but it does bring together a lot of concepts that we've been learning in the past. So we looked at the quadratic formula, and this is to complete the square, which is very similar to quadratic formula in that we get the same answer. So one question that a lot of people have is, what came first, the chicken or the egg? Or in this case, which one came first, the quadratic formula or complete the square? So that's kind of what we're going to discover today. Alright, so what I'd like you to do is go ahead and attempt to complete the square on this problem here. So if you'd like, go ahead and pause the video and give it a shot. See if you can get there on your own, and then once you've finished, you can come back and watch how it's done and make sure that you did it right. Okay? Alright. So here we go. Ax squared plus bx plus c equals 0. Alright, so the first thing we want to do is get rid of c. So we're going to subtract c from both sides of the equal sign. And that will get us ax squared plus bx equals negative c. So hopefully that all makes sense. Just got rid of c. Our next step, we want to get rid of a. And we've done that before. We just divided it away. So we're going to divide each term by a. And that gets us x squared by itself plus b over a x equals negative c over a. So hopefully that's making sense so far. Alright. Now remember, once we're at this point, we need some side work. So we want to keep it separated from our actual work. The side work is very important, but if you don't keep it separated, the whole problem will get really jumbled, hard to see, hard to follow, be very difficult to do. So, alright, so our side work here, we're going to take our new b, which is b over a, and we're going to divide it by 2, which is the same as multiplying by 1/2. Dividing by 2 and multiplying by 1/2 are the same thing. And that's going to get us b over 2a. b over 2a. Okay? I just multiplied across. So b times 1 is b. A times 2 is 2a. So b over 2a. We're going to take b over 2a, and we're going to square it. But remember, this number here, this b over 2a, that's a special number. That's special, so we want to save that. So we're going to save that b over 2a. So b over 2a squared is b squared over 2a squared. So 2a squared. B squared that was easy, but 2a squared, 2 squared is 4, and then a squared is a squared. And there we go. So b squared over 4a squared. Okay. So I've got x squared. I'm coming back over because I've got all the work I needed. So I'm coming back over. I'm just writing down everything I had before. B over a x. But then I need to add my new c, which is b squared over 4a squared. So plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. So hopefully this is making sense so far. It's pretty complex, but it's doable. At this point, I do want to simplify. I want to simplify the right-hand side of the equal sign. So I'm going to do that in my side work, kind of like we did before. Negative c over a plus b squared over 4a squared. So common denominator between a and 4a squared, well, I need to multiply the first term times 4a. 4a times a is 4a squared. So if I do 4a over 4a, that's just 1. 4a over 4a is just 1. So I can do that and multiply it times anything. So times negative c over a plus the b squared over 4a squared. So hopefully that makes sense. I just have my original statement from above, but I'm multiplying the first term by 4a over 4a. I don't want to reduce that. I want to multiply it across. So I end up with negative 4ac over 4a squared plus b squared over 4a squared. So they now have a common denominator, and I can add them together to get negative 4ac plus b squared over 4a squared. Remember, this is a special number here. This is very special, but this number is what I need. I needed to combine these to get this, and so we're almost ready to use the special number. So we're about to. All right, so we're back up here. We're going to write this down. X squared plus b over ax plus b squared over 4a squared, you'll see, equals, and we're going to write this down because we simplified this this piece here. So this became b squared minus 4ac over 4a squared. I just took and put the b squared first, minus 4ac. Instead of having a negative 4ac plus b squared, I wrote b squared minus 4ac, which maybe sounds familiar to some of you if you've been using the quadratic formula. Okay. All right. So now we're going to factor, but remember we don't have to factor it normally because we've got this special number. So we get to just write x, and it's a plus because this is a plus sign, and also notice this is a positive number, so that helps too. So b over 2a squared equals b squared minus 4ac all over 4a squared. Okay. So hopefully this is looking familiar. Maybe not perfectly familiar, but it's looking familiar to some of you. So the next thing we're going to do is square root both sides. Remember, when we square root, we need to make a plus or minus. Because we're square rooting a square, and they're going to cancel each other out. And that's going to leave us simply with x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. Okay. I should have tried to simplify this. 4a squared, the square root of 4a squared is just 2a, because the square root of 4 is 2 and the square root of a squared is a. So I could have written that, and I should have, so I could have saved myself a step here, but that's okay. So x plus b over 2a equals plus or minus the square root of b squared minus 4ac. Notice I can't simplify the square root of b squared because it needs to be the whole thing inside of the square root that simplifies. And 4ac does not simplify square root. The square root of a is not a pretty number, so we don't want to do that. Same with c. Even though the square root of 4 is 2 and the square root of b squared is b, we can't simplify that further. But the square root of 4a squared is simplifiable because they're being multiplied. So the square root of 4 is 2, and the square root of a squared is just a, and we have a 2a. And notice we have common denominators. So we're going to subtract b over 2a from both sides to get x by itself. So subtract b over 2a, subtract b over 2a, and ta-da, we are done, and we end up with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which hopefully you recognize as the quadratic formula. So we have gone from completing the square in one page. We went from completing the square on ax squared plus bx plus c equals 0 to the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And hopefully that does answer the question, which came first, the chicken or the egg, or in this case, completing the square or the quadratic formula. And if you're still not sure, let me know and I can help you out with that. All right, have a wonderful day, and I'll talk to you later. There is a lesson attached to this video, so hopefully you can get it done. If not, let me know and I'll try to help you out. All right, thank you so much. Goodbye.